Hi everyone, myself B. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the topic on Fourier series within the limits c comma c plus 2l. Within the limits c comma c plus 2l. Okay, c comma c plus 2l and minus l comma l also. Okay, first I have to discuss with Fourier series of function defined in minus l comma l, minus l comma l. For that, let f of x be defined in minus l comma l and be periodic with the period 2l. What about the here the limits minus l comma l or c comma c plus 2l? For that period is 2l. There also minus l comma l, that complete okay period value b minus a formula, from that l minus of minus l, that is 2l. Okay, that period is 2l. For that series formula, here the series expansion f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n pi x by l plus b n sin n pi x by l. Okay, from that here a n b n formulas, a n is equal to 1 by L integral minus L to L f of x into cos n pi x by L dx, and Bn formula 1 by L into integral minus L to L f of x into sin n pi x by L dx. And similarly, what about A naught formula? A naught formula 1 by L into integral minus n to L f of x dx. 1 by L into integral minus L to L f of x dx, that is a naught, a n and b n formulas. For that, this is the formulas for the within the interval minus l comma l, and the similar formula for c comma c plus 2l also. There c comma c plus 2l means there in place of l I am taking 2l, and here c to c plus 2l. Okay, now I have to discuss with the related questions. And for the first question, Fourier series. Okay, and continuation of the theory, Fourier series for even and odd functions in minus L comma L. Uh, Whenever if you are taken interval minus L comma L means first we have to verify the function is even and odd function. This is the general formula for the minus L comma L. First we have to, for the given any equation, first we have to verify if the function is even or odd means, then the given question, that means the series will be reduced. Okay, easily we can get the answer for the after verifying even or odd function. For that, first I'll take what about even and odd function within the interval minus L comma L. Let f of x be defined in minus L comma L if the function is even. If the function is even, for that case, if the function is even means, for that case, what about the formula for the series f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n pi x by l. Okay, this is the formula. Here the function, okay, once observe there within the interval a n b n. Generally these are the formulas, but if you are verifying the function as even, for that case, the general formula will be reduced to 1 by 2 a naught plus sigma n is equal to 1 to infinity a n cos n pi x by l. For that, what about a n there? Okay, formula 2 by l into integral 0 to l f of x cos n pi x by l into dx. This is the formula for the a n. And similarly, what about a naught? A naught formula 2 by L into integral 0 to L f of x dx. First, if you are verifying the function is even means directly what's the formula? This is the formula, and for that this is a naught and this is a n. Okay, and similarly, if the function is odd, okay, within the limits minus L comma L, if the function is odd, for that case Fourier series f of x is equal to sigma n is equal to 1 to infinity bn sin n pi x by L, where bn is equal to 2 by L. What about the formula of bn? Bn is equal to 2 by L into integral 0 to L f of x into sin n pi x by L dx. Okay, if the function is odd, means for that case that series is very simple, only here the series with that Bn. Okay, then Bn formula is 2 by L into 0 to L f of x into sin n pi x by L dx. Okay, when the limits are either minus L comma L or minus pi comma pi, means for that case for any function first we have to verify even or odd function. If you are verifying, means easily we can solve the question, or else it takes lot of time. Okay, for that in the above discussion, if you put 2L is equal to 2 pi, then L is equal to pi, we get the discussion regarding the intervals 0 comma 2 pi and minus comma pi and special cases. Okay, for that first I'll discuss with the first question. Express f of x is equal to x square as a Fourier series in minus L comma L, in minus L comma L. For that, first, what about the given function x square? Okay, for any function within the limits minus L comma L or minus pi comma pi, means what's the concept? First, we have to verify the function as even or odd function. Okay, first of all, okay, from the definition of even or odd, here, what about the function even or odd function definition? F of minus x is equal to f of x, means it is even. Even. F of minus x is equal to minus f of x, means odd. Okay, for that, here f of minus x is equal to f of, what about the given function, minus x square. That means here the given function f of minus x is equal to minus x whole square, that is equal to x square. Again we get the same function f of x. Therefore, the given function f of x as even function. For the Fourier series within the limits minus L comma L, already we discussed, if the function is even, means only the formula for f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n pi x by n. Okay, for that first find out a naught and a n. First I am finding a naught. What about the formula for the a naught? A naught means, okay, this is second point. Okay, first I am finding a naught. Whatever the formula for the A naught is equal to, A naught is equal to 2 by L into integral 0 to L x square dx. Function is x square. What about the integration of x square? That is x cube by 2 by L into x cube by 3. That limits 0 to L. That is, after substituting the limits, that L cube by 3 minus 0 cube by 3. That is, here 2 by L into L cube by 3, 1 L cancel. That is 2L square by 3. Here 2L square by 3 as the A naught value. Similarly, I am finding an. What is the formula of an? An means 2 by L into integral 0 to L f of x into cos n pi x by L dx. For the 2 by L into, what about the function there? F of x is equal to x square. That is 0 to L x square into cos n pi x by L dx. That is 2 by L into, okay, once observe, after substituting the function, again which is in the form of what? This is in the form of integral uv, that is 2 by L into, okay, u as x square, I'll take u as x square and v as cos n pi x by L. From the 2 by L into x square into cos n pi x by L integration, that is sin n pi x by L, and x coefficient there n pi by L, and x square integration, sorry, x square differentiation is 2x into integration of sin n pi x by L, that is minus cos n pi x by L by n square pi square by L square. Again continue, that minus 2x differentiation is 2. Okay, here 2 into, again integration of this cos n pi x by L integration is sin n pi x by L, and here minus, and I'll take that minus exactly there also, that is minus by x coefficient n cube by L cube, n cube by L cube. Okay, and what about the, after the integration, what about the limit 0 to L? Here we have to continue that procedure up to the constant terms of the u. Here u first differentiation as 2x and the next differentiation as 2. If you are continuing the next differentiation, that is 0. Therefore, stop the procedure for the integration of UV and substitute the limit points with 0 comma L. Okay, then 2 by L into, already we discussed, if the sign term within the limit 0 comma pi or 0 comma L means directly that limit the sign are zeros. Once observe, if you are substituting in place of x as L, here LL cancel, sin n pi value 0, and here in place of x I am substituting L, LL cancel, sin n pi value 0. If you are substituting in place of x as L, LL cancel, cos n pi we get some value there. Further, now here directly sin n pi value 0 within the limits L, and within the limit 0, sin 0 0, and there also 0, but cos 0 value 1. Therefore we have to substitute the limits only in the cosine term. Okay, for that, after substituting the limits 2 by L into, okay, then 2 by L into 2L cos n pi by n square pi square by n square, after substituting the limits. From that, here 4L square into cos n pi by n square pi square, and cos n pi value minus 1 whole power n into 4L square by n square pi square. Okay, this is En. Already we discussed with A naught. Now we know that A naught and En, substitute in the first equation. What about the first equation? This the given series as the first equation. Now substitute, that is f of x as x square, and what about a naught 2l square by 3 in the formula, in the denominator 2 is there, 2 to cancel, then directly there l square by 3 plus sigma n is equal to 1 to infinity. What about an? Minus 1 whole power n by n square pi square into 4l square cos n pi x by l, that is l square by 3. There I'll take minus, okay, that is 4l square by pi square I'll take outside, and n value I'll start with 1, that is minus 1 whole power n plus 1 by n square into cos n pi x by L, cos n pi x by L. There, now expand the sigma value with n is equal to 1, that is 4l square by pi. If you have taken n as 1, that is minus 1 whole power 1 plus 1, that is 1 by 1 square into cos 1 pi x by L, that is cos pi x by L, plus cos minus 1, 2 plus 1 means minus cos 2 pi x by L by 2 square. If you have taken n as 3 means that is positive cos 3 pi x by L by 3 square. This is the required series for the function x square within the limits minus L comma L. X square as even function, so that easily we are getting the Fourier series with A naught and An. Thank you. Thank you for all. This is the concept of the even and odd functions within the limits minus L comma L. For the next class, we will discuss some other topics in the Fourier series. Thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.